Hello everyone, and welcome to another day in basic chemistry. So last time I talked about ionic bonding and naming of ionic bonds, and that nomenclature can actually be continued on to talk about covalent bonds for some of the basic covalent structures. And so I'm just going to talk about the comparison and contrast between ionic and covalent bonds and give you guys a basic understanding of covalent bonds. So let's take a look at my wonderful periodic table. Now with ionic bonds, we have metals bonding with nonmetals. So if we just draw a line through here and say everything on this side of the line is metal and everything on this side of the line is nonmetal, a basic way of understanding it, a very basic way of understanding it, is ionic bonding will like to involve both nonmetals and metals. Now with covalent bonding, it will involve nonmetals to nonmetals and metals to metals. However, more commonly you're going to see the nonmetals to the nonmetals, especially when you get into organic chemistry. And so, with that, we'll just scroll back up to here, and I'm going to give you guys a basic ionic compound. Let's go Na bonding to Cl. The very, very simple salt. So, if you remember, Na wants to have a +1 charge. Cl wants to have a -1 charge because of where they're located on the periodic table. So we have the 1- over here, and we have the +1 over here. And sodium is here, chlorine is here. Beautiful, easy to understand. So Na doesn't have that charge yet, nor does chlorine. What happens is Na has an electron here. Chlorine wants that electron because one electron is equal to a -1 charge. So what will happen is that one electron will be given to the chlorine, free of charge. It'll just be given. The sodium has no claim over that electron, at least as far as we know right now. So when that electron is given, sodium losing an electron gets a positive charge. Now chlorine gains an electron, and since electrons are negative, chlorine gets a negative charge. That's a pretty big negative sign. Let me try that again. A negative charge. And so positive and negative are attracted to one another. And so these two compounds will be attracted to each other by their polarity, because opposites attract. And that is the basis behind ionic bonding. Just remember, ionic gives its electrons and then they're polarly attracted. Covalent bonds do something different. So let's talk about H2O. Water. Water is a covalently bonded structure. It's polar, but it is still covalently bonded. And so with water, what we have is hydrogen, which desires a +1 charge, oxygen, which desires a -2, so I'll just write these charges that it desires up top. And so when you cross the charges, you need 2 hydrogens. So I'm going to put one more hydrogen over here. And so what's going to happen is oxygen is going to have 2 electrons that it's willing to share. Hydrogen has 1 electron that it is willing to share. As to how many electrons each element is willing to share, we'll talk about in other videos when we talk about valence electrons, but that's yet to come. And so hydrogen has this electron, which in order to get a plus charge it has to give up. So let's say that it is going to give it to oxygen. Now oxygen has this electron that it has that it's going to give back to hydrogen, and then these 2 electrons are just going to continue to circulate between the 2 elements. The same is going to happen over here. It's going to circulate and circulate and circulate. because these electrons, they are not given like ionic bonds, they are shared. It is very important to remember that word shared. Covalent bonds share their electrons. They share electrons to form a pair. It takes 2 electrons to form a pair. And so what we're going to draw water as is O, and we're going to draw this line to H. This line represents 2 electrons. And so we have this other line to this hydrogen, which represents 2 electrons. And these electrons are shared. And the same can go for a diatomic molecule. Let's say N2. This is a diatomic molecule. Now with nitrogen, if you look down here, nitrogen is in the +3 charge area. So since nitrogen is in a +3 charge area, nitrogen has 3 electrons that it is willing to share. And so we have another nitrogen over here that has 3 electrons that it is willing to share. So it takes 2 electrons to make a bond. So what happens is we're just going to draw a line across here, draw a line from this electron to this electron, and draw a line from this electron to this electron. Now, if you know within drawing this compound, we have nitrogen +3 bonding to nitrogen, which has a +3, and then you cross the charges, and you have N3, N3. You go to the most common denominator, and since they both have the same thing, we can say N to N. And so then that can be reduced, since there's 2 nitrogens, to N2. However, look at this 3. We have 3 bonds. The denominator is 3. If you want to call it a denominator, I like to. It's really a subscript. So what we can do is, when we draw the molecule like this, is draw 3 bonds. Now how's that for cool? And so this is what we would call the structure of nitrogen. I just erased a circle to draw a new one. But anyway, that is pretty much the basics of covalent bonding. And you just need to remember they share electrons in pairs. And ionic bonding also deals with pairs, but we'll get into that more when we talk about valence electrons, which should be coming out soon. It'll probably be within my next few videos. So stay tuned.